All right, 6.7 Modeling with Algebra. Hey, just a heads up, somewhere through this video, I'm going to have you write a specific thing in the top right corner of these notes, and you're going to need to do that in order to get full credit. So please be paying attention the entire time to figure out what it is that you need to write in the top right corner of your notes in order to get full credit. Want to check and make sure you're always listening to my notes. It's a very important part of the learning process. Okay, objectives. Students will be able to construct an equation or inequality that models, should be an S there, a certain context and manipulate equations to solve for certain variables within word problems. Okay, when constructing a model to represent a situation, you have to first be able to tell what kind of situation it is. It is either linear, quadratic, or exponential. You talked about linears when you were in Math 1. We've talked about quadratics in this class in Chapter 3, and now we've talked about exponentials in this chapter. And so you've seen examples of all of these. And now when we see a word problem, we have to first kind of determine, well, which one of these scenarios is it? And there's some key words that we're going to look for in the word problem itself to find out which one it is. So next, think about your type of function and what the key features you would need to write a model, right? So we have all these different types, right? So if it's a linear, we're going to need some type of slope or rate, right? Some type of rate of change, and then a y-intercept or a starting value. If it's a quadratic, we're going to need a vertex, right? HK, remember that's really, the H is the location of our max or min, and K is the max or min. We might need the roots or the zeros. We've talked about this before. That's if it's in factored form. We're going to need the y-intercept or starting value. We might need any one of these, okay? These are just little features that we might need. And remember, the y-intercept is really the C value when it's in standard form. So we got vertex form, where we have the vertex, factored form, where we have the factors, and therefore we get the roots or the zeros, standard form, where we get the y-intercept. This is all review. For quadratics, pick the form that matches the information you're given. So if they give you the vertex, use vertex form. If they give you the roots, use the roots form. Or if they give you the y-intercept, use the standard form. All those, that kind of makes the most sense. You don't have to use those, but obviously be easier to use the form that matches the information you're given. All right, exponential, we have this standard form that we've been looking at this whole chapter. And to write this, you're going to need the principal amount, or that's the starting amount, P. This is also the y-intercept. It's the y-intercept because if you plug a 0 in for t, we usually do this in terms of t instead of x. But if you plug in a 0 here, 0 over anything is 0, and anything to the exponent of 0 is just 1. So when you plug in a 0, you can just get the p times 1, which is just p. And so that's why you get your y-intercept is also your p-value. R is the rate or percent increase or decrease. This is really important. This is what you're going to, you might want to write this down. You're going to be multiplying by this, right? Because, right, you're multiplying by that value over and over and over again. That's what exponential does, is it you plug in some value for R and then you just keep multiplying by this to some exponent over and over and over again, and that's how it grows so fast. A is the amount of time it takes for one change to occur. So, you know, if they're saying, hey, it happens every 5 minutes, and your t is in minutes, then that's going to be a 5. And t just represents your time. All right, let's do a problem like this. On his way home from the laboratory, Louis realized that he left a test tube containing, I'm going to start highlighting stuff that I think is important, 2,560 yeast cells in the lab. Every 3 minutes, the number of cells in the test tube increased by 50%. If the number of cells reaches 98,415, I'm going to highlight this one in red as well, I'll explain later, the test tube will explode. Naturally, he turned around and rushed back to the lab. It took Louis T minutes to return to the lab, and he found the test tube intact. Okay. Right away, I noticed two things that we need to jot down. The first thing I notice is that over here, this 98,415, if the number of cells reaches this, the test tube will explode. And then it says that he found the test tube intact. So it doesn't explode, so that means it didn't reach this number. So right away, I think that whatever we get is going to be less than 98,415. It does say to write an inequality in terms of t-dimensional situation. Well, I think that our number of cells is going to be less than this, because if it was more than this, right, so I'm going to write an equation over here, or an inequality over here, But if it was more than this, it would explode, and we know that it doesn't explode. So hopefully that makes sense as to why I know it's less than 98,415. Now, I got a lot of information here, and I'm going to go up here, and I first have to determine, this is the other thing I kind of noticed, I have to determine what type of problem it is. Well, it's important to understand quadratics they square numbers over and over and again. This one you add numbers to it over and over again. And this one you multiply by numbers over and over again. Well, if it's increasing by 50% every 3 minutes, that means we're multiplying it by 1 plus 0.5 over and over and over again. 1 plus an r value of 0.5. So this tells me it's exponential. So let's go ahead and just put in our equation. So I'm just going to write p. Remember, it's 1 plus our r value, which I'm going to write in green. And then it's going to be whatever our t value is divided by whatever our a value is. And hopefully you can kind of tell what these values are because I color-coded them, but we'll explain how we know all that in just a second. So, once again, I got 98415 is going to be greater than. Well, what is my p? Remember, my p is my principal amount. It's my starting amount. And it says when Louis realized that he left a test tube containing 2,560 yeast cells. So it had that much in there. That's how much it started with. So I'm going to write 2560. And then we have 1 plus the R value. Remember, the R value is the rate or percent increase. They're telling us it's 50%. So I'm going to write 0.5 for 50%. It's the same thing. The t value, that's my variable, so it just stays just like that. The a value, well, remember they said that this happens every 3 minutes. It goes up by 50%, so the a value is just 3. And that's essentially it. We could clean this up a little bit, and it would just look like, I'm going to write it all in one color now that we have all the parts there. It would just look like 98,415, sorry, my one's a little weird there, is greater than 2560, 1.5 t over 3. Now, this is a fine answer. It is possible to simplify, like you could probably move this 3 that's on the bottom, you can make that like 1/3 times t, then move that inside, but it's not really necessary. This is a fine answer just like this. They didn't ask us to simplify it into any certain form or anything like that. They just said write inequality in terms of t that models the situation. Well, this is inequality. It's not maybe the only inequality I could write. There's things that I could do mathematically to both sides here, but it is inequality and it does model this situation in terms of t. So we're in good shape. Let's go to the next page. But before we do that, I'd like for you to put the name of your favorite band or musical artist in the top right corner of this page. Top right corner, favorite band or musical artist. Okay, so now we're just manipulating formulas. That just means we're using our algebra skills to get variables where we want them to be. So, example 2, we can convert temperatures from degrees Fahrenheit to degrees Celsius using the formula C equals 5/9 parentheses F minus 32, where C is the temperature in degrees Celsius and F is the temperature in degrees Fahrenheit. This is a useful little formula. When I went to Cancun, everything was in Celsius and I didn't really know what that meant, so I had to keep converting it to Fahrenheit to figure out what that temperature meant for me to understand it. So it says rearrange the formula to solve for F. So we're going to take this formula and we're going to rearrange it to solve for F. So let's go ahead and do that. I'm going to zoom in here. So let's just start by rewriting this whole formula. I got C equals 5/9 F minus 32. Now remember, I'm trying to solve for F. So let's just highlight that. I'm trying to solve for F. Well, in order to do that, basically, I need to work from the outside in. I need to try and attack this problem from the outside. So outside here, then a little bit less outside, and then finally get F all by itself. So the farthest thing outside I see is this 5/9. And so what I'm going to do is I'm going to try to attack that 5/9. So right now it's being multiplied by 5/9, but if I multiply both sides by the reciprocal of that, so if I multiply both sides by 9/5, something beautiful happens. And that is that the 9s are going to cancel out, the 5s are going to cancel out. And so now on the right side, I would just have f minus 32. Don't know why I wrote in red, but, and on the left side, I would have 9/5 c. Okay, so now f is a little bit closer to being all by itself. All I have to do now is add this 32 because it's subtracting 32, so I want to undo that. I want to attack that. So I'm going to add 32 to both sides. So I'm just going to say, right, add 32, add 32. And so I'll go back to black. Don't know why I have it in red, but 9/5 c plus 32 would equal f. So now I have a formula for Fahrenheit, where now if I just plug in the Celsius, I get the Fahrenheit. So even though I started with one where I plug in the Fahrenheit and it kicks out the Celsius, I just basically found the inverse, and now I plug in the Celsius and I get the Fahrenheit. All right. So the next part of this question says, what temperature in degrees Fahrenheit is equivalent to 21 degrees Celsius? Well, now that we have this formula, we could just take 21 and plug it in. So let's just go ahead and do that. I got 9/5 times whatever my Celsius plus 32 equals my Fahrenheit. Well, my Celsius is 21, so I plug in a 21. This is not a nice, neat number, unfortunately, but I could do 9 times 21 divided by 5. I could do 9 divided by 5, then times by 21. Any way I do that there, I end up with 37.8. So this is 37.8. You could go to your calculator, do it yourself. Plus 32 equals Fahrenheit. 37 plus 32 makes 69, and then we also have a 0.8 there, so this ends up being 69.8 degrees. So that's a pretty comfortable temperature for me. Maybe it's cold for you, but I like that temperature. And so if you're at 21 degrees in Cancun, Mexico, that's not bad. All right, let's go to the next problem here. Practice number 2. In finance, the future value of a single sum formula is useful when you want to know how much a given amount of your money will be worth at a given date in the future. So you can invest some money, figure out what it's going to be worth in a year, 5 years, 10 years, based on a set interest rate. The future value, f, of a single sum is calculated using this formula. F equals this guy, which is very similar to our exponential problems, where p is the present value, meaning the amount of money we have right now. And r is the interest rate expressed as a decimal, and n is the number of periods, or periods meaning like years or months or whatever is the way the interest is calculated. Sometimes it's calculated monthly, yearly, whatever. That's going to depend what unit the n is. Rearrange the formula to solve for present value p. Okay, so let's just start off with the original formula is f equals p times 1 plus r to the n. And I am trying to get this p value all by itself. Well, here's the deal. Technically, all of this is all one term. And so it's actually pretty easy to get all by itself because all I have to do, oops, let's go back to my pen. All I have to do is divide both sides by this whole term. And then these terms would just cancel out. And so the formula is simply p equals f divided by 1 plus r to the nth power. Okay, so we have a formula where p is all by itself. Good. Next, what is the present value of an investment worth $4,000 in 5 years at a 5% annual interest rate? Okay, so I want you to try to solve this on your own. And then if not, don't worry, I'll work it out with you. But basically, you got all the information here. They're telling you they want to know the present value. And it's going to be worth $4,000 in 5 years, and it's going to have a 5% annual interest rate. So I think this is actually pretty doable. You're going to need a calculator, but that doesn't mean it's hard. So go ahead and give this a shot, and then check back when you're ready to check your results. All right, so first thing you got to know is what are all these values? What do they mean? Well, if it's going to be worth $4,000, that's your future value. So I highlighted that for 4,000, and I plugged it in up here on top. 5 years is our time, so I highlighted that green, and I plugged that in here for t, or for n in this formula. And then r is your interest rate, which they tell us is 5%, so I wrote it as 0.05. A common mistake here might be to write it as 0.5. Remember, 5% would be 0.05. And then from there, really, I just took this and plugged it into my calculator. 4,000 divided by 1 plus, or 1.05 to the 5th power. Make sure that when you raise to the 5th power, you're only raising this to the 5th power, not this whole thing. So make sure you put it in the calculator right, with parentheses. A way that you could kind of put this in the calculator is to just write parentheses 4,000 divided by parentheses 1 plus 0.05 parentheses exponent 5. All right, when you do that, you get 3,134 and about 10 cents, but this does say to round to the nearest dollar, so the nearest dollar would just be $3,134. So if you put in that much money, in 5 years, it'll be worth 4,000. Kind of nice to know. All right, there's no summary on these notes, but make sure you ask your question right here at the end of the notes, and I'll see you guys next time.